Hi, Kaushik. How is your school going? They are able to maintain social distancing.
Yes, they are giving homework after homework, sir.
They're giving
All
homework there, huh? What class they are doing for maths now?
now they are taking algebra.
They're taking what?
Algebra.
Algebra. Okay. Now, by the time we finish it, we'll be finishing from this side. So you'll be doing very fast. And
Okay.
now you will see that maybe little bit more work is done. But by November, you will feel you are master of everything. So that is a process.
Yes.
Okay. Let us now, let me first share the screen.
Okay.
Now we are going into statistics and probability. Okay. Last class I talked about Mahalanobis. Mahalanobis National Statistics Day. Okay, because Nehru was a socialist, right? India started out being a socialist country. So that is where Mahalanobis was a great statistician. And the word statistics itself comes from the word state, which means the data about the state. Okay. So what we are going today, see, statistics is unavoidable. This chapter will be helpful for you anything in life, everything in life. Whether you become marketing, whether you start a business, okay, whether you become economics or whatever you're planning for your future. Okay, even if you do a political opinion poll, advanced research, you become a PhD, doctorate, everything, this is the only thing. Okay. So what is statistics? Scientific methods for collecting. First you collect, then you organize, then you summarize. What you do? Collect data, then organize the data, then summarize the data, present the data, and analyze the data, and come to some meaningful decisions. Okay. So, yeah. What happened, ma? Last class, 9th standard, you would have learned about the measures of central tendency. Okay. Measures of central tendency means what? Arithmetic mean, median, mode. You remember all these three you learned in 9th standard. Very easy.
Actually, last year they skipped this. Last year all they gave all pass, so they skipped it.
Oh, they didn't do anything, huh? Oh, very sad. See,
Stopped here,
that
sir.
is what the problem of skipping things. That is why I don't skip. See,
Yes,
if they're skipping and now you are entering into problem now.
Yes, sir.
Okay,
They
now
told all pass last year, sir. Suddenly they stopped.
very sad, very sad. Okay, now we can't do anything in 10th standard. We have to do what is given in the syllabus. Okay, go and read arithmetic mean, median, and mode. Okay.
Okay, sir.
At least you should mean arithmetic mean. At least you should read in 9th standard textbook. Don't throw away a textbook. Read arithmetic mean section alone in 9th standard textbook. Okay.
Okay.
What is data? You are observing some facts. You convert it into numerical terms. That is data. What is observation? Each entry of data, one row of entry of the data is called an observation. Okay. What is a variable? Suppose you are doing a customer survey or a political opinion survey. See which those quantities that you are noting. Okay, x of I, where x of 1, x of 2, x of 3, x of 4, like that, x of n. That is only a variable. Then you also have something called frequency. How many times that variable occurs? That is called the frequency of that variable. Okay, for example, you are recording the marks of the students. Okay, suppose one student is getting 70 marks, two students are getting 70 marks, three students are also getting 70 marks in your class of 50 students. Then the frequency of the data is 3 and the variable of the data is values x of 1 or x of 2, whatever, no, and the physical value of the data is 70, like that. Okay, don't worry. If you have not studied arithmetic mean, we'll be studying, revising it here. Very simply, we will go. Okay. Now, suppose 10 piece of data is given, 10 data is given. Okay. Then what is arithmetic mean? The sum of all the observations, 10 data you are given, all the 10 observations, you add up all the 10 observations and divide by 10. Okay. Or if you want 15 data, add up all the 15 data and divide by 15. So what is arithmetic mean? It's called x bar. Okay, you usually denote it by x bar. You denote it by x bar. Then This is the one, no, x bar, like this you have to denote it. Sum of all the observations, that's mean x1 plus x2 plus like that, it goes till xn divided by n. Okay, that is sigma x of I divided by n. That is the x bar. This is the mean. Okay. Now, that is the simplest way to calculating a mean. For that is for ungrouped data. Okay, raw data, point data that is coming. Okay, there's a direct method to use. This is the formula. Arithmetic mean is equal to, I told you, no, sigma x of I is equal to 1 to n divided by n. That's what is given here. If you increase the, see, so small. I is equal to 1 to n sigma x of I divided by n. That means sigma means the sum of all the values of x. Okay, that is the first one. Then the other one, this is ungrouped data. For group data, they are telling group data. Group data means you are getting data, say the number of marks is obtained is 70, 80, 100, like that. How many students are getting the marks? 3 students are getting 70 marks. 6 students are getting 100 marks, like that. If you have data like this, then this is called frequency. This is called x. Okay. Now that becomes a group data, which is a direct method you can follow. Okay. In that case, instead of sigma x of I by n, which is for direct method, you write sigma f of I x of I by n. That's all. Very simple. Okay. And n will become sigma f of I. Okay. That means you calculate sigma f of I. This is add up f. Okay. What you are getting? 3 plus 2 plus 6. 6, 7, 8, 9, 10, 11. Okay. This is sigma f of I. That will be n. That will be your n. Then you have to multiply f of I into x of I. 70 into 3, 210. 80 into 2, 160. 100 into 6, 600. Then you have to sum up all of that. 600, 760, 860, 960, 970. So this will be sigma fx. Sigma fx. So that is what is given. Sigma fx divided by sigma f. F is so 970 divided by 11, like that. Okay, you understand? Then there is assumed mean method. Assumed mean method. Okay. Now suppose you have the data like this. 70 comes 3 times, 80 comes 2 times, 100 comes 6 times. And you are want to simplify the calculation. You want to simplify the calculation. What you do, you just assume the mean already. You take 70, 80, 100 and you think, okay, mean is going to be 85. You just assume A is assumed mean 85. Then what the data will become, you have to calculate D1 now. Instead of f into x, f will be there, x will be there. Now what you have to calculate? You have to calculate D. D will be x minus A. Then you have to calculate f into D. All right. X will be 70, 80, 100. F is the same, 3, 2, 6. Okay. Now assumed mean is 85. Assumed mean is 85. So x minus 85 you will have to calculate. 70 minus 85 is minus 15. 80 minus 85 is minus 5. 100 minus 85 is plus 15. Okay. Then you have to do f into d. F into d. 3 into minus 15 minus 45. 2 into minus 5 minus 10. 6 into plus 15. Okay, 90 plus 90. Then you have to calculate sigma fd. That will be 90 minus 55. That will be 45. Then you have to calculate sigma f again, 6, 7, 8, 9, 10, 11. So n is equal to 11 is equal to sigma f. So that is where you have to now do this sum. Okay. So 45 by 11. That will be the new thing. That is sigma f of I d of I divided by sigma f. Okay. This plus assumed mean 45. Assumed mean was 85 plus this one. So this is how you should calculate. Let us say this is 44. Then 85 plus 4. 85 plus 4 will be 89. So the real x bar will be 89. Like that you should. Okay. Then what you should do? Step deviation method. Step deviation method is assuming you are going to get some class data. Okay, let me do it in a different way. Let us do it in a different way. Step deviation method. Okay, what in step deviation method? Instead of getting point data, you get continuous data. Continuous data, frequency distribution plus frequency distribution. Okay, always it will continuous data will always come as frequency distribution. What do you mean by continuous data? Instead of giving point data like 70, 80, 100, you are giving a range of class 0 to 10, 10 to 20, like that you're giving 70 to 80, 80 to 90, and 90 to 100. Okay, this is becoming the class. Now you are giving frequency. Okay, what you had? This was 6, this was 3, this was 2. You are given frequency. What you have to find out now? You have to find the midpoint of the class. Okay, this is called lower class limit. This is called upper class limit. Okay. To find the midpoint, midpoint becomes your x now, new x. UCL plus LCL by 2. That is, sorry, UCL minus LCL by 2. Okay, 80 minus 70 by 2. Sorry, 80 plus 70 by 2. Okay, 80 plus 70 by 2. 150 by 2. That is 75. So this mid value x. Instead of the, because you don't have x, mid value you should take as x, 75. Like that, if you do mid value 90 plus 80 by x by 2, okay, 170 by 2, that will be 85. So you will get 85 here. Then 90 plus 100 by 2, 190 by 2, that will be 95. Okay, you get 95 here. Like that, you have to take mid value. Okay, once you take mid value, you have something called the length of the class, that is called C. Length of the class is UCL minus LCL. That is 100 minus 90, that is equal to 10. So C is equal to 10. Mid value is equal to 75. Okay. Now what you have to do, the formula that they are giving is, you now assume a mean. Okay. Let us assume same thing. Assume the mean is 85, like last time itself. Okay. Now the formula they are giving is, you have to find deviation. Okay. From mid value. Okay. What deviation from mid value? You have to do x, which is this one, minus a divided by c. This is the mid value. Then you have to do f into d. Then sigma fd you have to find out. Then same way sigma f you have to find out. N is equal to sigma f. 6, 7, 8, 9, 10, 11. Yep. As usual, n is equal to 11. Okay. This and all nothing you have to do. Okay. Now here d is equal to x of I minus a by c. 75 minus how much is assumed mean? 85. Assumed mean is 85. 75 minus 85 by 10. Minus 10 by 10 is equal to minus 1. So d is equal to minus 1. Then 85 minus 85 by 10. That is equal to 0 by 10 equal to 0. So you put 0. Then 95 minus 85 by 10. That is equal to 10 by 10. That is equal to 1. So you put here 1. Then you have to do f into d. 3 into minus 1, minus 3. 2 into 0, 0. 6 into 1, 6. Then you calculate the sigma FD. 6 plus 0 minus 3. Okay. 6 minus 3 is 3. This is the sigma FD. Now what you have to do? The mean x bar is equal to A plus this time what you have to do? Sigma FD by sigma F or N into the whole into C. Okay, because here you are dividing by C, here you have to multiply by C. Okay, that is a formula. Okay, and deviation is x bar minus A by C. So this is the shortest way you can revise the thing. I am going to post this in your WhatsApp now. Okay.
Okay.
Now this three things only you'll have to go and revise in your statistics in 9th standard. These three methods: direct method, assumed mean method, and step deviation method. You go and revise and come, because that will be very much needed. Okay, we can't spend a lot of time on that. Now that is called mean, is called a measure of central tendency. What is mean called? Mean, median, mode. All three are averages, measures of central tendency. That means data is here, no? Suppose this is the data that is given. Now 1 and 3 are pulling it downward. 7 and 9 are pulling it upward. Okay. Central value is, central tendency is 5. Okay.
Okay.
So average, how you come? 1 plus 3 plus 5 plus 7 plus 9 divided by 1, 2, 3, 4, 5 divided by 5. 9 plus 7, 16. 16 plus 5, 21. 22, 23, 24, 25. So 25 by 5. That is equal to 5. 5 is your mean. Okay. Now, why it is called a measure of central tendency? See, this data is, in all this data, this 5 is sitting at the center of the entire value of data. You are able to see 1 and 3 are on the one side, pulling it one side. 7 and 9 are pulling it upward. 1 and 3 are pulling it downward, but 5 is in the middle. That is why it's called central tendency. Okay? Measure of central tendency. Okay. This is one way to, one characteristic important measure of the data. If you want to give all the data and understand it with only a single value, so much data is given, 10 pieces of data is there, but you want to understand it with a single value, then you take the measure of central tendency, will give you a single value. Okay, that will give you the average or the center around which all the values are distributed. Okay, the rest of the values are scattered around this central value. That is the idea. Now you have to talk about measures of dispersion. This is the opposite of measures of central value. Okay, now following data you see, no, 25, 20, 45, 93, 8, 14, 32, 87, 72, 4. How much this fellow scored? He scores 4. Highest he scored how much? 93. Then he scored 87, 72, very high scores. But he's also scoring very low scores, 8, 4, 14. You understand? Yes. So what is the range? Range is 93 on one side and 4 on another side. Okay. So the difference between the scores are 89. So this fellow is very scattered. This data is very scattered. Okay. Or this data is very heterogeneous. Data is very heterogeneous. Look at this other fellow. Okay. This other fellow. But to look at the average, when you take the average mean of this fellow, you have to sigma x of I by n. N is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Because there are 10. N is equal to 10. Okay. Sigma I by, that is why you are getting 10 here. Total of all the scores and divided by 10, you get 400 by 10, which is 40. So average is 40. X bar or arithmetic mean is 40. Okay, average is 40. Take the second fellow. He is also scoring 10 scores. Okay, but what is his lowest score? Oshik, what is the lowest he scored?
So 10.
Enna. Batsman B, what is his lowest score?
Lowest score, sir. 26.
26, yes. What is his highest score?
50, sir.
50. See, what is the range? Range is 50 to 26.
Okay.
Very small range. This range is only 24. That fellow range is 89. This fellow range is only 24. Okay. That means he's very consistent batsman. His data is not scattered. Not scattered. Okay. It's very close together. Right?
Yes, sir.
Close together data. All his scores are close together. Okay. That means it is very homogeneous. Very similar. Very similar. Okay.
Okay, sir.
Okay. Now, you understand one important thing. Why do we need a measure of dispersion? Because if you take the measure of central tendency, both the fellows getting the same arithmetic mean of 40. All right.
Okay, sir.
But the data is very different. This fellow is scoring consistently. He is not scoring very high nor very low. That other fellow batsman A is scoring very high, very low. Okay. So how do you differentiate between the two data? Only if you get the average as 40 for both. So you need another measure in order to get the correct idea about the data. Unless you have the second thing, the measure of central tendency alone will not give you the right picture. So you need the measure of dispersion, which is the second number that you need to calculate. Okay. Now look at these two figures. Look at these two figures. Batsman A, see, very scattered. How much run he scored? Very scattered. But batsman B, see how much run he scored. It's all coming almost similar, correct?
Yes, sir.
Almost similar. But this fellow is going like that, going like that, going like this, like that. You understand? So
Yes,
this is very scattered. This is very homogeneous. Very close, okay, very unscattered, almost very similar, or homogeneous means similar. Okay, that is the thing. That is why, but both the fellow average is same. So how to get the idea of the data now? So you need, other than the arithmetic mean, you need a measure of dispersion, not only a measure of central tendency. So how much scattered it is, you need to measure. That measure is called measure of dispersion. Okay, there are a few ways to measure that. Okay, what are the measures? There are 6 ways to measure that. One is range. Range I already showed you. Another one is mean deviation. Mean deviation we won't study here. You will study in 11th standard. Quartile deviation also you study in 11th standard. Then what you will study here? You will study standard deviation and variation here. What you will study? Range, standard deviation, and variation you will study here.
Okay.
This one, this one, this one. Only 3 things you are going to study here. Okay. Other things you will study in your coefficient of variation also. Mean deviation, quartile deviation, you will not study here.
Okay.
Okay. First, let us study range. Range is very simple. I already showed you what is range, so you can understand. The difference between the largest value and the smallest value range. That's all.
Okay.
So in the previous thing, this fellow had score, no? He had score 93, then he had scored 4. So this is the largest value, this is smallest value. So 93 minus 4 is 89. That is the range. R is equal to 93 minus 89. That's all. Very simple. Then coefficient of range, very simple. L minus S divided by L plus S. Okay. That is divided by 93 plus 4. That is equal to 97. So what you have to do, L minus S, 89 divided by 97. Okay. If you use calculator, you can find that value. That will be the coefficient of range. That's all. You understood, no? Now
Yes,
let us do a simple example and you will understand very further. Find the range and coefficient or range of the following data. 25, 67, 48, 53, 18, 39, 44. Okay. What is the smallest, what is S here, smallest value?
sir.
In this data, what is the smallest value?
18, sir.
18. Yes, equal to 18. What is the largest value?
67, sir.
Yes, 67, largest value. So range is equal to largest value minus smallest value. 67 minus 18. 17 minus 8.
13, 29.
49. Okay. Range is only 49. That's all. Coefficient of range is same thing. 67 plus 18 you have to find now. 7 plus 8, how much? 15. 6 plus 1, 7 plus 1, 8.
8.
So 49 divided by 85 will be the coefficient of range. If you use calculator, you can find 0.567. That's all. Okay.
Okay,
Very
sir.
simple. Nothing to worry about this thing. So you must be able to do the problem. Example 8.2. Let us do example 8.2. Here, your book has made one small problem. Okay.
Okay, sir.
I don't think it is correct of them to say. Yes, what is the highest value?
Yes, sir.
Highest value
Highest value 8, sir.
28. Okay.
Okay, sir.
This is X. This is F. You have to take
Okay,
X.
sir.
What is lowest value?
18, sir.
16. Okay. So this is only wrong. 16. So the range is from 28 minus 16. So range is 12, not 10. Range is 12. Okay.
Okay, sir.
So don't forget that. Very important. So example 8.2, very important. Lowest
Okay.
number is 16. S is smallest is 16. L is largest is 28. 28 minus 16 is 12. Okay. Now let us do example 8.3. Now this is giving small twisting, very small twisting. The range of a set of data is given. R is given, largest value L is given, find S. Okay. R is equal to L minus S. Okay. What is given? 13.67 is equal to 70.08 minus S. Okay.
Okay, sir.
Okay. Take S this side. S is equal to 70.08 minus, and take 13.7 this side. Minus 13.67. 8 minus 7, 1. 10 minus 6,
4.
10 minus 6, 4. 9 minus 3,
6, sir.
6 minus 1.
5, sir.
So this value is correct. This is correct. 70.08 minus 13.67. Okay, what you have to use the formula? Range is equal to L minus S. R is given, L is given, find out S. So what you have to do? You have to take S to the other side. S is equal to L minus R you have to take. That's all. Then find out L. Okay, L is 70.08. R is 13.67. Just minus. That's all. Okay. That is all range problem. Range problem, very simple problem. Let us go to the real problems. Now, this is what we told about mean. Now, we are going to do something from the mean. We are going to take variance and standard deviation. Okay. What is a derivation from the mean? Okay. Now, suppose there is a set of data, x1, x2, x3, n observations are given. And the derivations, the deviations from the mean x bar are x1 minus x bar. Okay. Okay. What is we are telling? Suppose 1, 3, 5, 7, 9. These are five values. N is equal to 5. Now this is 5 is the mean. X bar is equal to 5. Deviations from the mean is x minus x bar, x1 minus x1, x2 minus x bar, x3 minus x bar, x4 minus x bar, okay, and x5 minus x bar. Now, what is x1 minus x bar? 1 minus 5, that is equal to minus 4. What is x2 minus x bar? 2 minus 5, sorry, 3 minus 5, that is minus 2. Third one is 5 minus 5, that is 0. Fourth one is 7 minus 5, that is equal to 2. Fifth one is 9 minus 5, equal to 4, okay. Minus 2, minus 4, 0, 2, 4, okay. Now,
Okay.
what you have to do, you have to calculate the sum of the x bar, the whole square. Okay, that means x1 minus x bar, the whole square. Okay, now one important feature is always the deviations, the sum of the deviations from the mean will be equal to 0. See here, minus 4 minus 2 is minus 6. Plus 2 plus 4 is plus 6. Plus 6 minus 6 is equal to 0. Okay. So sum of the deviations will always be 0. Now, what we are telling here is, don't take sum of the deviations. Take the square of the sum of the squares of the deviation. That means minus 4 into minus 4. First one, minus 4 squared plus minus 2 squared plus 0 squared plus 2 squared plus 4 squared. That's what he's asking to take. Okay. How much minus 4 squared?
Minus 2 squares.
How much is minus 4 into minus 4, man?
Minus 4 into minus 4, minus 8. Sorry,
Right.
minus 16.
Huh?
Minus 16.
No. Minus 4 into minus 4 will be minus 16. No. Plus 16.
Into
Minus into minus is how much?
Plus, sorry.
Plus 16. So this is 16 plus 16. Okay, minus 2 into minus 2, how much?
Plus 4.
Plus 4. Plus 0. 2 into 2?
4.
4 into 4?
16.
So 16 plus 4, 20. Again 16 plus 4, 20. So this will be 40. Okay. So x of I minus x bar, the whole squared, sigma, that is the meaning of this, is equal to 40. You understand?
Yes, sir.
What is the meaning of this formula is given here? Sigma I equal to 1 to n. In this case, n is equal to 5. Okay, that means xi will be, first time it will be x1, second time it will be x2, third time it will be x3, right? I is equal to 1, 2, 3, up to 5 like that. You understand?
Yes, sir.
x4, then x5. That's what you got it. x1 minus x2, x bar, x2 minus x bar, x3 minus x bar. Then you do square of the everything. Square this. Then square this. Okay, so minus 4 squared, minus 2 squared, 0 squared, 2 squared, 4 squared, that is equal to 40. That is only sigma x of I minus x bar the whole square. Okay.
Okay, sir.
You understood what this formula means?
Yes, sir.
Each value of x of I will be changing. First time it will be x1, second time it will be x2, third time x3. But every time you have to subtract arithmetic mean only. Okay, then square it, then add it like that till x5 minus x bar squared. Okay, then all the addition is equal to sigma x of I minus x bar the whole squared. That is the meaning of that. You understood? It must be very clear. Now only you are going to go to the most important step. Now we saw this already. X of xi minus x bar is variance. Okay, let us go to variance. That note is stupid. The mean of the squares of the deviations from the mean is called variance. Okay, let us take it very simply. The mean They are taking the mean of something from the mean. This is mean. Okay. The square of the
Okay, sir.
deviations. First to take deviations. Deviation is nothing but x of I minus x. Okay. This is
Okay,
deviation.
sir.
This is mean. This is deviation from the mean. Then square of the deviation means you have to square it. Okay.
Okay,
And
sir.
then you have to take x2 minus x bar, the whole square, like that, plus x3 minus x bar, whole square. Suppose only three values are there, divided by 3. Okay, because n is equal to 3. That is the variance. That is called variance. So xi minus x bar the whole square plus x2 minus x bar the whole square plus xn minus x bar the whole square is divided by n. Okay. This is I am
Okay,
giving for n is equal to 3. General formula is n. Okay. So like that. That is only variance. This is your learning a new formula and a new word, variance. Variance is a measure of dispersion. Okay. Variance is
okay,
denoted by sigma squared. Please understand. Variance is denoted by sigma squared. Okay. Variance is nothing but x of I minus x bar the whole square divided by n. That's all. I
okay,
is
sir.
equal to 1 to n. That is the meaning of this. Okay. So this thing you should easily remember. You don't have to memorize it. What you have to do, deviation. Deviation is mean. Deviation from the mean and the square of the deviation from the mean and then the sigma of that divided by n. This is a other mean. Okay. Next mean. So this mean only we are taking as variance. This mean is arithmetic mean. Okay. X bar. You understand the difference?
Yes, sir.
This mean is sigma squared. This mean is arithmetic mean sigma. I mean arithmetic mean x bar. So sigma squared is equal to I is equal to 1 to n. The sigma of x of I minus x bar the whole squared divided by n. Okay. Now let us go to another important thing. Because all the time now we are coming to the main thing. You take the square root of variance is called standard deviation. Okay. So variance was denoted by sigma squared. Standard deviation is denoted by sigma. Okay.
Okay,
Standard deviation is denoted by sigma. Okay. Just take the square root of variance. What was variance? Variance was sigma xi minus x bar the whole squared divided by n. That whole thing you take the square root, that is equal to standard deviation. SD, standard deviation. Okay. This is the most important thing. Because now that you understand what is standard deviation, you are having many methods for calculating standard deviation. That only we are going to see today. Let us see for ungrouped data today, and tomorrow we'll do for group data. Then next day we'll do exercise 8.1, and then we'll move on to probability another time. Okay.
okay, sir.
Direct method, very simple method. Direct method, very simple method. Okay. Now here you have xi minus x bar the whole square. This is in the form what? A minus b the whole square. So you stay a squared plus b squared minus 2ab. Correct? A
Yes,
minus b
sir.
whole square. Okay, so this is a squared. A squared plus x bar the whole squared minus 2 xi into x bar. Okay, divided by n. N is retained like that. Okay. Now we are going to go one step further. Okay, that means you remove the first part, sigma xi the whole squared is removed separately, divided by n. Then minus 2 into x bar into x of I by n. That is also you remove separately. Plus x bar the whole squared by n will come how many times? Because you are telling sigma xi the whole squared minus 2 xi into x bar plus x bar the whole squared. Okay, divided by n. Okay, so because of that, xi the whole squared by n. Okay, this one you take separately. You will get this one. Then minus 2 x bar. X bar is always a constant. Xi by n. Okay, sigma is there. Sigma means you have to keep adding. What is the meaning of this? Xi the whole squared means x1 squared plus x2 squared plus x3 squared, like that till what? X of n squared. Okay, that's why it's coming like this one. So x of I squared by n first sigma. Then 2x bar. Okay, x bar is coming minus 2 sigma minus 2 x of I into x bar. X bar is coming outside. It's a constant. Okay, and
Okay.
x of I is keeping variant x1, x2, x3 like that till x of n. Okay, so like sigma x of I by n. Okay, then this is x bar the whole square. Okay, every time x bar the whole square will come. Okay, every time for x of 1, x bar the whole square will come once. For x of 2, x bar the whole square will come plus x bar. No, for x of 3, x bar the whole square will come. Like that it will come. For x of n, x bar the whole square will come. Okay, so how many times it will come? 1, 2, 3, 4, n times, n into x bar the whole square. Okay, that's why it's put n times. So n into n. Okay, what will happen? This n and this n will cancel off. Okay, so you will have only x bar the whole square. That's why you are having only x bar the whole square. This is correct. Okay, minus 2 x bar into this is what? This is what? Sigma x of I by n is what? Sigma x of I by n. This is nothing but arithmetic mean. Okay, sum of all the data divided by number of data is equal to x bar. So that is why he is putting x bar into x bar. 2x bar is derived from here. This one also become x bar. So minus 2 into x bar square. That is why this has become minus 2x bar squared. Minus 2x bar squared plus 1x bar squared. It will become minus x bar squared. That is why this area has become minus x bar squared. Okay. So x bar the whole square is arithmetic mean the whole square. Arithmetic x bar is equal to what? Sigma x of I by n. X bar the whole square is equal to sigma x of I by n the whole square. Okay, that is why x bar the whole square has become sigma x of I by n the whole square. Now you don't have to remember how to derive the formula. That is the good news. Okay, you don't have to remember how to derive the formula. Only you have to remember the formula. So what is the formula you'll have to remember? Standard deviation direct method is equal to sigma x of I squared divided by n minus sigma x of I by n the whole square, and take the score whole root of the whole thing. Okay, see, don't get confused. This is mean. So sigma x of I by n the whole square, this one. Okay, here sigma x of I the x of I squared by n. Okay, this is one data that divided by n, and minus this, then take the whole square root, that will be sigma. No, sigma. Okay, we will get it very clear when you do an example. So let us do an example. You don't have to arrange in ascending order. Only for median you have to arrange in ascending order. For mean, finding standard deviation, you only have to use the formula. Don't have to arrange in ascending order. Okay.
Okay.
Now, let us do an example. Number of televisions sold in each day of a week. Okay, let us take this, and if you do that, then you will understand very simply what that means.
Okay.
Say there are 7 days in a week. Okay. So number of television sold in each day of the week. So n is equal to 7. The data is x1, x2, x3, like that till x7 is there. It's 13, 8, 4, 9, 7, 12, and 10. Okay.
Okay, sir.
This is the number of items sold. This is the x value. Now, what is the formula for sigma? Find the standard deviation. Sigma x of I the whole squared by n minus sigma x of I by n the whole squared, the whole root. Okay. What you have to find out? You have to find out, therefore, sigma x of I squared you have to find out. Then sigma x of I you have to find out. Then you have to divide both by this also you have to divide, this also you have to divide by n. Okay. Now what you are going to do? That's only you are going to do. X of I squared you have to calculate. Why? Because you have to find sigma x of I the whole x of I squared. Okay. So this will give you sigma x of I. If you add up all this will give you sigma x of I squared. Okay. N is already given. N is 7. Okay. So this formula, root of sigma x of I squared by 7 minus sigma x of I by 7 the whole square. Okay, that is how. N is already given. Only you have to find out sigma x of I squared and sigma x of I. Okay. So first one you are finding sigma x of I. How you are finding? 13, 8, 4, 9, 7, 12, 10. You have to add up everything. If you add up 7, 8, 9, 18, 19, 20, 21, 22, 22 plus 8, 33. 3, 4, 5, 6, 63. Okay. Sigma x of I is 63. Okay. So minus 63 by 7 the whole square, that side. Now sigma x of I square, 13 into 13, 169. 8 into 8, 64. 4 into 4, 16. 9 into 9, 81. 7 into 7, 49. 12 into 12, 144. 10 into 10, 100. Okay, if you calculate all of this, 623 it is coming. Okay.
Okay, sir.
So sigma x of I the squared is equal to this value, 623. Already n you know 7. Okay, this only you have to find out. How many times 7 will go in 63?
749.
7 into 9 is 63. Okay. So this will go 9 times. So 623 by 7 minus 9 squared root of 623 by 7 we have to find now. Okay. 623 divided by 7. It will go 56 8 times. Then 63 is remainder. 63 it will go 9 times. So 89. So becomes 89. 9 into 9 is how much? 89 minus 9 into 9 how much?
81.
Very good. 9 into 9, 81. So root of 89 minus 81. 89 minus 81 how much?
8.
8. Okay. So that is equal to square root of 8. That is 4 into 2. That is equal to 2 root of 2. That is equal to 2 into 1.414. That is 2.828. That is the answer. Sigma is equal to 2.828. Okay. He's given us 2.83. Okay. You got that?
Yes, sir.
Okay, so your textbook, the calculations are not given properly. I'm going to post this in your notebook. I mean, in your WhatsApp, you study this carefully, you will get everything, every other sum you can start doing easily. Okay. Now this is the simplest, easiest direct method. There is another method, no, mean method. Another way of finding standard deviation is to use the following formula. Okay.
Okay, sir.
Directly do deviation is equal to xi minus x. Okay.
Okay.
This is the direct formula. Okay, then that becomes x of I minus x bar is taking as deviation. Okay, deviation from x of I. That simplify that. D is that means then sigma d. This is the same sigma d of I the whole squared by n. Okay, that is the other way to do it. Okay. Now we are going to do that method. That method you have to do. Okay, example 8.5 will do. We'll see what is happening. Are you able to see?
Yes,
You're having
sir.
laptop only, no?
Not now, sir. Now I'm using a phone, sir.
Your phone, don't use the phone, ma. You will not learn anything.
Okay.
Never use the phone, only use the laptop. If you use the phone, you will not learn anything. Only problem of eye problem you will get. Everything will be waste. Okay. Always use laptop. Never use phone. For your school also use laptop. Never use phone. You will not learn anything. Nothing will register. Okay. Now, amount of rainfall for a particular season for 6 days. 6 days. This is x1. Then this is x2 like that. This is x6 given. Okay. Now you are arranging the numbers. You don't have to arrange the numbers. Mean is nothing but sigma x of I by n. Okay. N is what? 6 because there are 6 days. N equal to 6. Then you add up everything. Sigma x of I is x1 plus x2 plus x3 till x6. Okay. Add up everything divided by n. So 11.4, all of that you add up becomes 90. 90 divided by n is 6. So your mean is what? 15. Okay. So first step in this method, step 1 is to find x bar or mean, arithmetic mean.
Okay.
First step is always find the mean. Okay. Then only you must go for finding standard deviation in this method. Now mean is 15. Now what you have to do? You put all the tabular values 11.4, 12.5, 12.8, 16.3 and all of that. Then you calculate D. D of I is nothing but x of I minus x bar. X bar is 15. So x of I minus 15. All right. So 11.4 minus 15. Okay, this is 15 is more, minus 15. 11.4 minus 15. Therefore, 3.6 minus 3.6. So it's minus 3.6. Same way, 12.5 minus 15. Minus 2.5. Okay. So minus 2.5. Then 12.8 minus 2.2 you will get. 16.3 is bigger than the mean. So 0.3, 1.3. This will be plus 1.3. Same way, 17.8 is bigger than 15. 0.8, 2.8. So you are getting 2.8. Then 19.2 minus 15. 0.2, 4.2. So 0.4.2. Okay. That is what you got. Now you got D. Okay. What is the standard deviation? We solved D1 the whole squared by n. Okay. This is the method. This is the formula. Okay.
Okay, sir.
Okay. xy minus x bar the whole squared by n. That is the meaning of this. This is the direct method. Now you got dy squared. You keep adding all of that. You get sigma d1 squared. Sigma di squared is equal to, you add up calculator, we won't use waste time on that. 51.22. Okay, 51.22. N is 1, 2, 3, 4, 5, 6. N is equal to 6. So 51.22 by 6, the whole root. Okay.
Okay, sir.
That's all. So 51.22 by 6 is 8.53. Root of 8.53, you use calculator. Okay, don't keep trying to do mental sums. Use calculator. Root of 8. You know how to find root using calculator, right?
Yes, sir.
Have a calculator there. You can find square root. Okay. Otherwise, it's useless thing. You have to find square root. So square root of 8.53 is 2.9. That's all. It's actually 2.84 something, 2.85 something, 2.9. That's all.
Okay.
So this is the second method. Now we are going to do the third method. What is the first method?
Sir.
First method is directly apply this formula. Sigma x of I squared by n minus sigma x of I by n the whole square. Okay, that is the first method. Second method is sigma d of I the whole squared, d of I squared by n the whole square root. Okay, for that you have to find deviation, that is xy minus x bar. So first you have to find x bar, which means x bar is nothing but arithmetic mean. First step is find arithmetic mean. That means add up everything and divide by n. Okay, that you get 15. After that, from 15, you have to find the deviation d of I. So if each value of x of I, you minus 15, you will get d of I. Then square of d of I. Then after square of d of I, calculate all the sum, you will get the sigma d of I whole square. And n is equal to 6. So sigma d of I the whole square by n only is your standard deviation. That also formula you have to keep mugged and use that wherever you can. Okay. So this is the second method. So where point data is given, you can use either method, you will get the same thing. You can also use now assumed mean method. Okay, that only you are going to do now. Okay. Time is already up. Assumed mean method. Now let us not do the derivation and all. We don't need derivation. Only formula you need. Okay. What is D that you need and formula you need? D is you first assume a mean. Suppose some set of data is given like that, the previous data was given. You assume the mean is 15. Okay, then assume the mean becomes 15. Then d of I is equal to,
okay,
or assume mean is 14. D of I is equal to that particular value, 11 minus 14. That is equal to minus 3. That is only d of I. Okay. So assumed mean minus then sigma x of I minus a. That is also there. Okay. Now standard deviation, once you put the derivation, the final formula will become very simple. You don't need to bother about how you derive the formula. Just need the formula. What is the formula? Sigma d of I the whole d of I squared by n minus sigma d of I by n the whole square. See, it is very similar to the other formula where you had directly x of I values, x1, x1, x2 directly used. What was the value? Sigma x of I squared by n minus sigma x of I by n the whole square. Remember, here wherever x of I comes, you just put d of I. Sigma d of I squared by n minus sigma d of I by n the whole square, the whole root. That's all. Sigma. Okay. Assumed mean method. Wherever x of I comes, you substitute d of I. That's all. Okay. That's all the formula. Okay. We will stop there and we'll come to your example next class. All right. Example 8.6. Unless we do some examples, we cannot do the homework. Okay, we'll take up example 8.6 next class. Okay, Ma. Very good. Thank you.